Okay, welcome to another ClearPoint Unlock Podcast. My name's Dave Shepherd. I'm the General Manager of Software at ClearPoint, and today's topic is mobile development. And I brought along our mobile practice lead, David Rawson. David.
Yeah, hi Dave. So just a little bit about myself. I've been working as an Android developer for about 8 years. I've worked on a number of different projects, including a large team with over 20 other Android developers and 1 million monthly active users.
Wow. Okay.
And
that's some scale.
Yeah, and I've also had the privilege to speak in front of my peers in a couple of conferences. So, for instance, Chicago Roboto in 2022 and DroidCon Vietnam in 2023. And I've even done a few contributions to open source projects. So yeah, that's me.
That's great. Great to have you here, David. So it's the Dave and David show today.
Yeah, that's right.
Okay, so I guess if we're thinking about mobile development, there are probably some unique challenges when you're approaching mobile development compared to, say, your backend development or your traditional or your web front end development. So do you want to talk us through the main challenges or the things that are the main differences or considerations between those two sort of styles of development?
Yeah, sure. So, okay, we'll start by giving a question back to you. So do you remember the days when, if you wanted to buy software, you'd walk into a brick and mortar store and the software would be in boxes on the shelf?
Yes, I certainly do. I've still got some in my cupboard, I think.
Yeah. So you take that software home and install it on your 486 or your 586 or whatever.
Yeah, remember those days?
And I think mobile development has more in common with that mode of distribution than it does with, say, a website that's updated multiple times a day, where the users just refresh a browser and they get the latest version. So with mobile apps, the code will be cut into a binary, like something that's going to run on the user's device. And that's similar to burning the CD in the old process. And then as the CD gets shrink wrapped and sent out. So in mobile development, do you upload your binary to the Google Play Store or the Apple App Store? And beyond that, it's out of your control, similar to how the box leaves the factory and you can't bring it back. So Giorgio Ross, in his book Building Mobile Apps at Scale, 39 Engineering Challenges, says that this is called mistakes are hard to revert. Once you've put your binary out in the open, then some users can't update, some users won't update. They might get stuck on that version, so you can't roll it back like a web deploy. So there's that challenge, which is not insignificant.
I'm assuming you can actually pull the app back out of the App Store, but that's probably quite a major thing to do. But I guess you can't force people to uninstall a version that they've already installed.
That's correct. There's things you can do, like you can do a force update. So you can make some kind of system where if the user's on a version that you don't support, you force them to go to the Play Store and click update. But that's quite a jarring experience, and it's not available to all customers. So, for example, if your new binary is using new APIs from Google and they're stuck on an old version of Android, they won't be able to do that. They have no choice but to uninstall. So there's some mitigations there, like you're saying, but it's not perfect, and it's certainly not the same as web deployments. So just one other thing that is a challenge for mobile development is that it's going out on a mobile device. So mobile device is taken with the user in the real world, and it has to deal with all the randomness and all the chaos in the real world. So for example, the users using your app when they're out walking and they see something, they see a flower they want to take a photo of, so they flick to the camera app and then back to your app, and your app has to support that state change, so they can't lose the state of the form, say, they were filling out. And same thing with things like if they wander into an area where there's no internet or there's slow internet, the expectation is that your app keeps behaving. So there's that challenge, which is the fact that the mobile device is going in the real world which is different from, say, a laptop that's plugged in where there's good Wi-Fi, or a desktop computer where there's an Ethernet connection constantly.
Yeah, okay. And do the mobile development tool sets or frameworks help you with those things? Are they or are they challenges that the developer really has to know what they're doing to overcome those?
That's a good question. There are tools to help with that. So Google and Apple, they will make APIs that will help you, for instance, support offline mode, which would resolve that situation of where the user wanders into a place where there's no internet. But it's not perfect, and the developers have to anticipate these various scenarios and engineer around them.
Yeah, so I guess from the product owner, you're hoping they've thought through those scenarios, and those are part of the requirements of the app. But I'd imagine there's times where they're not considered at the design time, and then when the app gets out there in the real world, it's used in quite different environments. So I'm guessing that's where the development team's experience comes through, because they'll anticipate that even though the product owner might say, yep, this will always be connected to the internet, there will be times when it's not, and having the app recover gracefully is probably quite a key thing for development teams to have in mind and build in. So awesome. Okay. So mobile development's been around for quite a number of years, and it's been quite a fast moving space. And so I would assume that a lot of organizations have got mobile apps that are sort of a little bit long in the tooth, that are ready for a refresh. And sometimes that can be an expensive thing to do, I'm guessing. So how would you go about making the case from, say, a technical point of view that your mobile application, your mobile experience needs to be refreshed?
Right. So there's a professor of computer science at Stanford, John Ousterhout, and he says that the most important component of evolution is death. So in other words, your software, or at least parts of your software, have to die in order to evolve.
Okay.
So often you end up with, like you're saying, an app where it's just barely good enough. It's just doing the job, but internally it's rotten. It's really hard to make a change. Everything's really slow. Every new feature you add adds the risk of bugs. So when software is in that rotten state, there's not much you can really do apart from refresh it, like you're saying.
Yeah. Okay. So that's your classical tech debt build-up. It affects mobile apps just the same, it sounds like. And so what does that refresh normally look like? Is it a build again from scratch? Is it or can you do a gradual update of that?
There's a philosophy in engineering where you should never rebuild from scratch. For instance, Joel Spolsky has a very famous article called The One Thing You Should Never Do, where he explains how a rebuild can set you behind your competitors. That being said, sometimes a rebuild is the only option, and there are famous examples of rebuilds. For example, Snapchat rebuilt their app, their mobile app from scratch, and Uber did as well. And then people say to me, okay, these are companies with big resources, but they also have big apps. So people don't realize how massive the Uber app is. It has to support all the different payment methods around the world, and all the different airports, and all the different regulations around the world. So their rewrite is not easy.
Yeah.
If a rewrite is not possible, then some of the best teams that I've worked on are actually constantly refreshing parts of the app, so rebuilding them, say, every 2 or 3 years, and it seems to work much better than to just let it rot. Letting it rot means that you can you're constantly risking your app becoming non-compliant. So Google and Apple are changing their policies, and of course there's government regulations that cause you to act. And if your app is really hard to change at that point, then you're like a hamster on a wheel, and you're just trying to catch up with all these changes, and you're not actually able to add any more value.
Yeah, that sounds exactly the same as most other forms of development. It's just bad practice to build it and leave it sitting there without any sort of TLC in terms of upgrading libraries, staying compliant. Security would be another one as well, I'm assuming. let's say that a product owner or our sponsor has decided that, okay, we are going to do a refresh of our mobile app, whether that's gradual or whether that's from the ground up. One of the choices is between rebuilding with a native app for Android and iOS. Most companies need to have both in the current market. And then there's these cross-platform applications where you can build in one language and deploy to both. How do you choose? What are the pros and cons of going with a native app versus a cross-platform development style?
Sure. So native development, where you have a separate iOS code base and a separate Android code base, and you somehow keep them in sync, it's kind of like the premium option. So it's where you want to attract devs who really care about making your app look like it's part of the phone. So for Google, that will be developers who really know about material design, for instance, and on Apple it will be developers who are passionate about human interface guidelines and so on. So that's the premium option, and according to some, the most expensive option. Then there's the cross-platform solutions. For instance, Kotlin multi-platform, where you write in Kotlin and you share code between Android and iOS.
It was Kotlin multi-platform. Yeah,
that's correct.
That's a newer one, isn't it? Yeah.
It is. So that came out of beta last year. So it is receiving support from Google and JetBrains. It's looking like a good option. There's Flutter. So Flutter is where you have a code base in Dart, and you share it between Android and iOS. And at ClearPoint, as you know, we've had the privilege to have a really amazing Flutter developer, and he's delivered some quality product in really aggressive time frames. So and he's been telling us that you can the concepts from Flutter, like stateful widgets and stateless widgets and changing state, are easy for web devs to learn. So you can leverage part of your web dev team for mobile, which is amazing. There's options like React Native, which is still strong, but despite receiving some bad press, for instance, when Airbnb dropped them. Yeah. So all these different options. The cross-platform solutions are not free, so there's a trade-off there. Like when something goes wrong with those solutions, you don't know if it's, say, your Dart code or whether it's an interface between the Dart code and the native frameworks and so on. So there's one more layer where things can go wrong, and that's not insignificant. But there's different choices there. I tend to think that for larger apps, the native approach works, and maybe for smaller apps, there's more scope to choose an option like Flutter or React Native or Kotlin multi-platform.
I've always thought of it as one of the aspects would be if you need high performance. If you're writing a game, you're probably not going to write it in cross-platform language. I'm guessing that access to the hardware or the device, is there still a large difference between what you can do with the device hardware, whether you need to talk to GPS or camera or sensors? Is that still something that you get the best out of a native app, or can you do all of those things in a cross-platform app these days?
Yep. So definitely, as you mentioned, performance is an issue. Like, you're going to get the best performance with a native app, and with hardware, those cross-platform solutions will have some wrappers around common hardware, like camera and maybe even Bluetooth. But the cutting edge stuff, the stuff with the most robust and full experience is going to be with the native development.
Yeah. Okay. So again, from a product owner point of view, you really need to have thought that through, because you can't probably be very expensive to change horses halfway through that race. Yeah. Okay. And just moving on to the way mobile development teams work, and thinking about things like measuring the success of a team, measuring the performance of a team. We've got things like DORA metrics, which have been around for a number of years. Things like deployment frequency, lead time for change failure rate, time to restore. They're common measurements for software development teams, whether back end, front end. Do the same metrics apply? Can you apply those those metrics, or are there different ways to measure a mobile development team success?
Right. So first of all, I think it's important to think about, is it Goodhart's law, like where if a measure becomes a target, then it ceases to be a useful measure. So there's a little bit of a danger of that with DORA, but at the same time, it is important to measure, right? You can't you can't just go on instinct and feeling alone. So getting into specifics, the first DORA metric is about deployment frequency. So deploys on mobile are called releases. So you could think of release frequency, but generally mobile apps will release every 2 weeks, maybe every month. High performers might release every week, and there's not much you can really do to move the needle there. It's very, very hard to increase the deployment frequency.
And is that because of the Play Store deployment time frame? You can't you can't release on demand multiple times a day like you can with, say, a web app, I'm assuming.
Yes, so some of it's from the unique challenges of mobile development, like the fact that it's a binary. You can't mistakes are hard to revert because it has to go through the Play Store, and it has to have a rollout period of rolling out to, say, initially 10%, and then checking if it works across all these different devices in the real world, and then if that's okay, then rolling out to 25% and so on.
Yeah, so I'm guessing that's the, what we talked about first was that old school, from days gone by, the software development mechanism, so the software shipping mechanism of sending out CDs. I'm guessing, these days there'd be no point in burning a new CD every day because you just can't get it into your customers' hands, the install process. So that makes sense. Okay, so so deployment frequency, that's one that's obviously has some constraints around it. What about the others? Things like lead time for changes, change failure rate. Are there any specifics in the mobile development team that would cause those metrics to change or to be measured differently, or are there better metrics to measure software development to mobile teams by?
Right. So for lead time for a change, again, that's difficult for releases where you don't control the release process, and there's the ramp up of say a week or at least a few days. So I would look, instead of lead time for a change, I'd look at lead time to the trunk branch. So that means, do you have robust continuous integration builds that don't flake all the time, that whether the developers are making pull requests that are very easy to review so they can land a change multiple times a day, whether the developers are able to review quickly and spot bugs and so on. So that, to my mind, would make more sense to look at than the totality of cutting code through to actually ending up in 100% of users' hands.
Yeah, okay. There was a couple of terms in there that you mentioned, that deployment pipelines not being flaky. Do you want to just describe what that means, and is that something that's different in mobile development to other areas of development?
Good question. So mobile builds are very, very complex. So let's take, for example, an Android app written in Java. You compile the Java code into JVM bytecode, and then it would go into another type of bytecode called DEX, and then all sorts of optimizations would be performed on that, because you can't have a massive 1 gigabyte binary going out to users. They just won't download it, right? So there has to be some optimization there. And because the mobile device has a very constrained set of resources in terms of battery life and CPU power and so on. So a lot of things can go wrong with builds. Like builds can, if you don't look after builds, they can stop randomly and fail for random reasons, which we'd call a flaky build. And those can be a real sap on engineering productivity, because you'll make a pull request and you expect the build to complete, and you come back half an hour later and it's failed for just some random reason, and you might retry that multiple times a day. So that's what we're talking about there with flaky builds, and also excessively long builds. Like you can end up with builds that take an hour or more if you're not careful, and engineers just hate that. They want to land their changes frequently, usually.
Yeah. So what I'm hearing is that the DORA metrics apply, but there are some boundaries, there are some constraints, there are some upper bounds, if you like, probably due mostly to that deployment process having to go out through an app store.
Definitely. I just thought I'd add for deployment frequency, I would be really interested in the deployment itself or the release itself. So in particular, what degree of automation you have there. And I'm not talking about automated tests running all over the app. That's quite difficult. I'm talking about things like automated code cutoff. So the person that's cutting the release doesn't have to worry about holding the window open so that last minute change can add.
Right.
Talking about things like automated tagging of Jira tickets so it's not a headache for change management, an automatic rollout of the change, so like 10% and 25% and so on.
Yeah, okay. Those things sound like they're the sort of things you could apply to web development as well. They're sort of good, modern, automated engineering practices. What about the actual building of the app and the signing of the build and deploying into the App Store? Is that something that's normally automated, or is that still a manual push button?
Yes, so that depends on the maturity of your team. We've seen a few projects where they've been able to automate that, like the signing of the release and the push to the app stores using tools like Fastlane. You can also build it using Gradle. So Gradle is a very flexible build system, and you can write your own plugins and your own tasks that do that.
Okay, great. Next area is really, which sort of related to that, is around the developer experience. So the developer experience is, in my experience, how developers feel, how good, how smooth, how frictionless is their experience of writing, testing, deploying that code. And again, we've got some constraints around mobile development and the actual deployment of the software. What else can we do around development experience for mobile teams? Are there areas that can be improved? Are there any particular constraints like we have for the deployment that affect the developer experience?
Right. Developer experience is really important for mobile apps. So the reason for that is you're trying to attract specialists in a limited talent pool, and if word gets out that you have a terrible developer experience, so for instance you're giving your developers eye cancer from making them look at Bitbucket, on-prem Bitbucket on a version from 2 years ago, and you're giving them a laptop with a busted battery where the battery's busting through the keyboard, then that people are going to know, and they're not going to want to join your company, they're not going to want to stay there. So apart from those things we mentioned, like the choice of the version control tool, one really important thing is the local build time. So that's when like the developer makes a change in the code, and they want to see the result, and they want to deploy it to an emulator or a test device that they have. And if that local build time gets really, really long, then it starts to sap morale. It really harms dev experience.
And what's really long versus good? Are we talking minutes, hours? Right.
So that it like many things in engineering, it depends. The build tools usually do have incremental builds. So different types of changes will result in different build times. But if you start to get like around 4 minutes, or we've seen projects with clean builds of like 10 minutes, it really does start to get start to sap productivity.
Yeah. Okay. So I'm guessing there's the tooling that you're using, and then does the speed of the development machine, sort of old laptops. I mean, that seems proportional to the grunt of the developer's machine, as well as the actual tooling that they're using. Okay.
Yeah, that's a really good one too, because you have to have someone who looks after the build to make sure that the build can utilize these beefy machines that you're talking about. So, for instance, if you're a really good build engineer, can parallelize your build so that parts of the build process utilize different CPU cores, and that can lead to a significant speed up as well.
So thinking about that developer experience and that, again, the deployment cycle, that's a bit of a constraint. How how can we enable sort of lean experimentation, that ability to try things out, get some fast feedback, decide if you're down the right track or the wrong track from a product point of view, or even sort of a technical spike? When you've got a 2-week release cycle, are there ways to enable that lean experimentation?
So the first question you need to ask yourself is, do I need to experiment on mobile? So for instance, if you have an audience split between mobile and web, it might actually make more sense to just experiment on web where things are more mobile, and then once the experiment is validated, then build the product on mobile.
Right, okay.
But if you do want to experiment on mobile, like some products will have no choice because all their audience is on mobile, then there are techniques to help you. There's a technique called server-driven UI, and that's when you make the mobile app like a JSON pretty printer. So you send a response in JSON or whatever format over the wire, and then the mobile app just responds to that. So you don't have to wait for a Play Store release in order to change the way your app looks. You just change the backend response. So the famous examples of that are Airbnb's Ghost platform. So they've written about that on their engineering blog, and we've experimented in ClearPoint with an open source framework called DivKit by Yandex. So that's certainly an option. And going beyond that, the cutting edge is what things like the Cash App team is doing. So Cash App is essentially having dynamic Kotlin code that's evergreen deployed with a technology like Zipline. It's really quite amazing to look at.
Yeah, it sounds like there's lots of new things in there that I haven't heard about. Sounds like it's an area that's definitely moved forward, and you have got a lot of those sort of experimentation tools available, despite the 2-week release cycle that you might be bound to. That's awesome to hear. And I'm guessing, those things are probably not at the forefront of your average mobile development team's awareness. So it's good to know that, there are ways to do that. Just thinking about, we talked a bit earlier around flaky builds and testing, mean time to failure, those sort of things. At a high level, how do we build quality into mobile apps? Are there specific techniques? Are there the ways that you do it for web development around automated testing? Do all of those things still apply in mobile, or are you in a completely different world when it comes to mobile and quality?
One thing that doesn't work on mobile is trying to completely cover the mobile app using UI tests. So the reason that doesn't work is the mobile UI testing frameworks are less mature than web, and they still have to run on hardware. So they have to run on a physical device or an emulator, and doing that you have to maintain your own device farm, and you have to deal with the remote debugging of an emulator or connecting to an emulator and so on. It can get very, very complex and very expensive. And those tests tend to flake quite frequently. So it's not really feasible to completely cover the app in UI tests. What can you do instead? Well, one thing that we found to work is trunk-based development, where you're avoiding long-lived feature branches, and the devs are making small atomic changes where the change is small enough where the really good devs can see the bugs and prevent most of the bugs there. It's things like lifecycle issues, things like not building accessibility into a UI component. And the other thing that works, if you look at how Alex Chu from Tarot.com talks about how Instagram was successful, he says that one of the reasons for their success and the quality of the app was their internal testing program. So that means when you have employees at your company signed up so that they receive the beta version of your app and try it before everyone else, and that's a really good way to catch issues early, that can't be caught via code review and can't be caught using UI testing.
Yeah, okay. That's great, David. We've covered so much from, sort of talking right at the start around the old ways of shipping software, and you've still got some of those constraints, but mobile development's got a lot of modern tools and techniques in there available. So I've certainly learnt a lot. So it's been great talking to you. Thanks a lot for your time, and we look forward to bringing you back at some point in the future. And thanks to everyone for tuning in to another ClearPoint Unlock podcast.